All right, well, let's go ahead and get going. So welcome back to spring quarter.
Yeah.
Hopefully, yay. Hopefully people have been enjoying a couple of weeks off from classes here at least. So CSE 223 is where we are. So advanced data structures in Java or something to that effect is the title of the course. It's a data structures course. It builds on what we did in 222. But it looks more at kind of ways that we can use some of these structures that we've developed. We'll also talk about some new structures perhaps, but we're going to be using things like trees and lists and stuff to do interesting projects and algorithms. And the other big change is it's Java, right? So we're kind of done with C at this point. Don't forget about C, right? C is always going to be useful to you. But we're not going to be writing C code. We're not going to be writing shell scripts. I'm not going to be asking you to write regular expressions or things like that. This is Java programming. Okay, that's really what our emphasis is going to be. But all the other stuff we've been doing will help you. Okay, the first Java assignment will be done on the Linux server. It'll be done from the command line, so you'll be compiling, you'll be using VI to edit and so on. So all that stuff will still help. And eventually we'll shift over to an integrated environment called Eclipse, and that's where we'll write the bulk of our Java code. So this course will probably feel fairly different from 222 and 224. For most people, this is the fun course, okay? Because you put in all this hard work and you've learned all these things, and now we get to use those to actually do some things that look more modern. Right, things with graphical interfaces or networks or good stuff like that. So this section is 2 days a week, Tuesday and Monday and Wednesday. We're going to keep it in sync with a daily class. And so the daily class for Friday, again, will be more kind of an open lab. People come in and work on what they want, unless we need time to catch up in there. Yay, the food's here. No thanks. All right, so what I want to do today is a bunch of things. I want to get through the administrative background material, which is going to be a lot of what you've already seen before, so there's not a whole lot that we'll have to do there. I want to talk about the labs, because that's a new component for 223. Over the others, there's a lab section that goes along with this course, so you'll have 5 labs to work on over the next 10 weeks. And they'll alternate with the programming assignments. One Friday will be a lab, the next Friday will be a programming assignment. So we'll talk about the labs, and then I want to talk about the first one-day program, which is actually a 2-day program. It's due Wednesday, and I want to walk you through basically everything that's involved in that. And then that'll probably take us up close to the break, and then we'll start talking about Java in more detail, and we'll start actually getting into the language. And in the past, I've spent a fair amount of time in the beginning of the course sort of laying the foundation of Java and some of the background and stuff like that. I think that's all useful and important, but I'd like to hit the ground running a little quicker this time and get people to where they're writing some code and starting to work with this stuff, and we can add the other details as we go along. So hopefully we'll be getting into some actual Java code by the end of today's class. So let me just run through some of the details. So, and all this stuff is on Canvas. Everybody has Canvas access, I assume. Anybody here that was not in 222 last quarter? We've got a few students who had it. I think they were in the previous one. But so if you were in 222, your account should still work. Login and password and all that should be the same. All right, so 223, data structures and object-oriented programming. There's an online text. It's free. You can download it. You can print it. You can read it from your tablet, whatever. I actually really like this text. It's about 1,000 some pages. And this person actually wrote all this stuff. It wasn't just copied from the Oracle documentation. There's nothing precious about this text, though. We're not going to follow it chapter by chapter. I'm not going to refer to specific examples in there. I'm not going to give homework from there and so on and so forth. But I think it's a useful text. It's as good as any But don't sit down and read 1,000 pages of textbook tonight just because that's the text that I have on Canvas, okay? It's not that kind of thing. It's a reference. But Java has been around for decades. There's lots of good resources out there. There's lots of good references. Gothard pinged me sometime last year and said, I got all these computer science books, and I don't know if you got a place to put them or what. So I went and looked. He had like 3 shelves of Java books. I don't know where they came from, but I took them all and I've got them in my office. So if you decide you want like a hard copy of a Java book, feel free to pop into my office and I'll show you which ones I have. And I mean, I can't recommend any of them in particular because they're just random books from Gothard, but and I don't think he knows where they came from. But if you want like a physical hard copy, you're welcome to come by and you can take one of these if you like it. So that's another option available. As I mentioned, after the first programming assignment, the programming assignments will be done in an environment called Eclipse. Okay, Eclipse is a free download. It's a whole development environment. And if you're going to be doing work on your own laptop or desktop, you want to go ahead and download Eclipse from that site and install it. And you're safe usually installing the latest version, which is Oxygen, I think. They go by letters. I think they're up to the O's. But go ahead and do that, and if you have any questions about it, let me know. But it's pretty straightforward. And that's a nice environment to work in. It's been an industry standard for a while. People seem to be shifting over to things like IntelliJ. And I think Android Studio is built on top of IntelliJ now. So Eclipse may be falling out of favor, I'm not sure. But all these things are kind of the same, right? They do the same basic things. It gives you an environment that lets you manage your files, lets you edit your code. It's usually got smart indentation and formatting. It knows about Java syntax, so it'll do color coding of keywords and strings and such. It will flag syntax errors for you. It will do all kinds of things that we'll see. Course outcomes, you can read these, but these are the goals of the course, basically. On to grading, which people usually care most about. So a series of programming assignments, 20% of your grade. We'll have some one-day programs. I don't know if they'll go the entire course, but it's I think, a useful way to keep pushing some of these concepts. So 10% of your grade from ODPs. Labs will be 10% of your grade, so there'll be 5 labs. And the labs will not be like 250, 270 labs where you're hooking up millions of wires and sparks are flying and all that kind of stuff, okay? The breadboard you get for these labs is seriously this big, okay? It's a tiny little breadboard. That's more than we need. We're mostly hooking up LEDs and switches, okay? It's just a way to sort of add some physical components on top of the Java. So labs are 10%. Service learning project, 10%. Your final submission for the service learning project this quarter is not a poster, okay? It's going to be a report. And there's a template for it on Canvas, but it's a full, formal written report, basically discussing your project, what you've done each quarter, the progress you've made, where you've gotten to, how it works, details, diagrams, code, everything, right? Future plans, et cetera, et cetera. So we'll talk about that later on. But that'll be 10% of your grade, and then midterm 20, final exam 30. So pretty straightforward. And then these are all exactly the same from every other class you've taken with me. As far as course policies, support services, DSS options and other accommodations, non-discrimination policy, student code of conduct, and so on. So I won't go through these now, but I encourage you, if you haven't read these recently, to reread them and ask me if you have any questions. So the other entry on Canvas is the course policies, and these are sort of specific to this section, this offering of this course. So my office, you know where I am, right? 115, other side of the collaboratorium. My hours are on my door, but you can also go to angrcs.com. That has hours for me, Zod, Carol, Tina. Assumptions. So I'm assuming at this point that you've got programming down, okay, in at least C. Algorithms, assignment statements, conditionals, looping, concepts like running sums, setting flags, things like that, functions, returning values from a function, stuff like that. The basic concepts, right? Those should be pretty much rock solid at this point, okay? Because we're going to use those to learn Java and learn about objects and write programs and implement algorithms. So you don't want to be struggling with those. So if you're not comfortable with these kinds of things, come and talk to me, okay? All right, so lab component. I'll come back to the labs in a minute. Anything else in here I need to say? Let's talk about emails. So I'm still fine with getting emails from people, but I'm going to ask you, before you send me an email, to ask yourself the following question. Is this an email that is only of interest to myself and the instructor, or is this something that has a broader scope? Okay, so if you want to send me an email and say, you know, I got to work a late shift tomorrow, I think I'm going to have a hard time getting the lab done, what do you suggest I do, right? That's obviously a one-on-one email, okay? But if you've got something like, you know, I read the programming assignment, I don't understand what you mean in this paragraph, right? Instead of sending me an email, go ahead and post it on the discussion area of Canvas, okay? And I'll get a note saying that, you know, there's a discussion there, and I'll go look at it. And if you want to send me an extra note and say, hey, I put this on Canvas, you know, that's fine. But I'd like to try to respond to these things in Canvas, because if there's something you don't understand in the assignment, something we did in class that was confusing, that sort of thing, probably I'm going to be getting emails from a bunch of people, right? So I'd rather see it in the discussion area, and I'd rather reply to it in the discussion area. And if you send me an email and it's, you know, not something that's personal in nature, I'll probably go ahead and post it in Canvas, and I'll send you a note saying I put this in the discussion area, see my response there. But I'd rather you put it up there yourself. So let's just play with that, right? If you're in doubt, just send me an email. But if it's more general and just a one-on-one, use the discussion area.
Are you going to comment on there as like reliably as you've been with emails? Or is it more of like you're looking for students to answer the question?
If I see a comment on there, right, and I think it's something that students will respond to, I might wait a little while and see if responses come in, and if not, I'll go ahead and chime in. But that's the other advantage of this, is a lot of times you're going to ask questions that other people have struggled with and figured out, and they may do a better job of explaining it than I will. So, cool. Exams, closed book, 4 pages, double-sided notes, same as before. All right, writing your own code. So even more so in this course than in other courses, right? It's really, really important, obviously, that you're doing your own work, you're turning in your own code, but you don't want to look at other people's code, okay? Online, in textbooks, you know, looking at a friend's laptop, things like that. Now, there's a textbook posted online, right? And there's some sample code in there, and that's fair game. And stuff that you've written is fair game, and stuff that we do in class or that I post on Canvas is fair game. But if you're trying to create a J-frame with 2 buttons in Java, okay? Don't worry if you don't know what that means. And we've talked about it in class, and you're not having success. Don't Google how to make a J-frame in Java, okay? For a few reasons. One, you're going to find some answers, and it's probably not going to be the same answers that we talked about in class. So you're going to start using different ideas than what we discussed in class, and the questions and problems you're going to run into will be different from the ones that we're anticipating in class, and the things that I say in class will do nothing to help you with that set of problems, because you're working with something very different now. Okay. 2, once you see code, you can't unsee it. And you're trying to figure out, how do I put this stuff together? How do I pass arguments to a main program, whatever, right? Once you've seen it, once you've typed it in after having seen it, it's in your brain from that source, right? You don't have the option of figuring it out for yourself. Okay, now that's fine in the sense that you know how to do it now, but you lost the opportunity to figure out whatever the mental block was that was stopping you from being able to do it yourself. And if you do that consistently throughout the course, the first time you get to that mental block is on the midterm or the final. And that's not where you want it to come up. So really, really, really work hard to resist the urge to look at sample code from outside sources. Okay? Shoot me an email or post something on the discussion board, right? I understand linked lists, I understand Java syntax, but I'm having a really hard time putting these together. Right? Here's what I'm trying to do, and it's blowing up. Right? So that's an email thing. Don't post code on the discussion group, but send me an email and we'll work with it from there. Okay? It's the same thing that I've said in other courses, but more emphasis in this one. The only possibility for late work is programming assignments, okay? And it's going to be 25 points if it's a minute late, and I'll take it up to 24 hours late, and then it's a 0, okay? This is not an extension, okay? Don't think of it as, I don't have to turn this in until Saturday morning, because we've got a 24-hour grace period, okay? It's going to cost you a quarter of your points if it's late. This is, you know, I was going to turn it in last night, and there was a thunderstorm, and all the power went out, and my internet went down, and I have electric locks, and I couldn't get out of my house, and this other thing happened, right, and the power came on at 10 the next morning, okay? I don't want you to get a 0 if something happens that really, really stops you from turning it in on time, so you can at least get, you know, 75 points on it. But don't be doing the calculus of, well, if I wait until tomorrow, you know, I'll lose 25 points, but I'll get 10 points back for getting this part working and so on. Try not to think of it like that, okay? The rest of the stuff is stuff we've said before, so you can read through that, but I don't want to dwell on it. All right, good so far? All right, so let's see. Let's talk about labs. So we've got these devices here. Yay, Patrick. Patrick made up the newest batch of these. These are standalone Linux boxes. Okay, it has a Raspberry Pi Zero inside, which is a standalone computer that boots up under Linux. It's got a USB port. The USB connection powers the Pi Zero and lets you communicate with it through a serial connection, i.e. PuTTY, if you're on Windows. So you can plug this thing in, and you've got a Linux box hanging off the side of your computer, whether you're running on Windows or OS X or even Linux. The cooler thing about this is there's these 40 holes on the side that you can plug wires into. And from Java, you can write code that will drive output voltages on these holes. You can drive them to 0 volts or to 5 volts. Or you can read a voltage coming into these pins and tell, for example, if a switch is pushed or not. And so we can write Java code that gets outside this box and interfaces with the real world. So you'll have a set of labs that let you do things like make an LED blink or read a switch or do things along those lines. The last lab, you're going to actually build a small network of these things using 3 wires and nothing else. So you can do it all in software. So it's a way to bring different parts of our brains into play instead of just sitting in front of a screen writing code hour after hour after hour, right? We get some physical outside the box things, and it's good practice. So we have 19 of these units, and they're in the collaboratorium. There's a cabinet in the back towards the right, towards that far back corner. It's labeled CSE 222, 23, 24. And there's 19 parts boxes in there, and each one has one of these, a really tiny breadboard, a few wires, some LEDs, and a switch. All right, so your first lab is due Friday, so I want to talk about your first lab. And your first lab is kind of a hello world. It's not really doing a whole lot of Java. It's not doing any Java, actually. It's really just kind of getting familiar with this thing, figuring out how to connect to it, what the basic setup is, where these things are in the lab, and it's also as part of this figuring out who you want to work with. Okay, nominally 40-some people taking this course, 19 parts boxes. So most groups can have 2 people. Few groups will have 3. Okay, so figure out who you want to work with, and then during break or after class, go ahead and in the cabinet where these things are kept, there's a sign-in sheet on the inside of the door. Pick a group number and just put your names in there, full names, and that'll be your group. All right, so let me tell you about Lab 1. Well, let me show you Lab 1 first of all. Let me show you what these things do. So I'm just going to plug this into a USB port, and I have a alias set up for this thing. So I'm basically running a program called Minicom, because that's like putty for Linux. And it prints out some boot up messages, and it'll wait for about half a minute or so, and eventually it'll give you a login prompt. And your login is Pi, and the password is Raspberry, and that's in the lab. And that's it. I'm on a Linux machine right now. And you know, there's files, and there's disks, and there's processes running, and there's all the important commands that we need, and so on and so forth. And there's Java. So it's a full Linux system, okay? It's just like Linux engrcs.com. It's got all the commands, it's got the man pages. It also has GCC, it's got VI, it's got a bash RC file, and so on and so forth. And there's not a whole lot in here right now. There's a directory of Python games, but I don't know if Python's installed. Well, it's installed, but I don't think it'll play the games because we don't have a graphical display set up. And in the lab, it tells you how to shut these things down, and you don't want to just pull this out because it's basically like a flash drive. Okay, there's an SD card inside that acts like the hard drive. If you just yank it out, things can get corrupted. So when you want to shut down, you say sudo shutdown -h now, and wait a few seconds, and it'll say power off or power down, and then you can disconnect, and then you're good to go. All right, so let's talk about details of this. For each lab, you're going to write a lab report. And I'm not going to get really bent about style and format of lab reports, but think professional lab report, okay? Don't think scratch a paper with some pencil marks on it that I did on the way to class because I forgot to write a lab report, okay? Type report, cover page with your name of your partners, course date, lab number, that kind of stuff. But I'm not really looking for, like, you know, introduction, procedure, materials, objectives, blah, 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 right? I'm looking for the contents more than the style. All right, so ground rules for these devices, right? I want you and your group members to think of this as your own personal Linux world, okay? This is yours to do what you want with for the quarter, okay, within reason. Okay, so each of these has a number on the front. It's either embossed or a few of them have it written in a Sharpie, and it matches the number on your parts box, and that should be the number that you signed up for, and stick to that number for the entire quarter, okay? If you're missing something from there, don't just grab someone else's box and use their unit, because you're going to be writing code, you're going to be leaving code on here, you're going to be using this code down the road. You might make yourself your own account, or you might decide to change the password on the default login, or you might set up a bash RC that, you know, makes the environment the way that you and your lab partners want it to be. This is your own little domain, okay? And you don't want to mess with somebody else's, you don't want somebody else messing with yours. So stick with the same unit, and if there's something missing with it, if there's something wrong, let me know, and we'll figure it out. please don't take these out of the collaboratorium. Okay, we had 15 of these last year, 20% of them disappeared. And that's a bummer because then we've got to make more and replace them. And if it disappears during the term, it's even more of a bummer. Which brings us to the bigger issue. Make sure that you coordinate whatever you're doing with your lab partners. Okay, if you decide you're going to change the default password on the login, that's great, unless you don't tell your lab partner about it. And they come in the next day and they try to do the lab and they can't get logged in. Right? So then they steal someone else's, and then they come in and they can't use it, et cetera, et cetera. So think about, coordinating with the people in your group. The other thing is, I'm going to ask you not to take these apart. Okay, the covers come off very easily. It's harder to put them back on, and it's much harder to put them back on without damaging what's inside. So when we rebuilt these this quarter, there were wires that were crunched inside because they were being pinched by covers being put back on wrong and things like that. You shouldn't need to take the cover off. Okay, everything should be doable through the USB interface. And if there's something wrong, again, let me know. Okay, avoid making major software configuration changes unless you clearly communicate with your lab partners. But other than that, you can do what you want with this. You can make your own account. You can give yourself pseudo access in that account. You can install software if you can figure out how to do it. And there are some tools on here that will let you transfer files if you spend the time figuring out how to do it. So have fun with it, okay? And there's the shutdown command, sudo shutdown -h now when you're done using it, so that you don't corrupt the hard drive. All right, so how do you connect to this? Well, if you connect to it from a Linux machine, your best bet is probably a command called minicom. So go ahead and install that, and the command is sudo minicom. There should be a -d in there. I'll have to put that in. -D /dev/gty USB 0. And then you want to do two things. You want to set the baud rate. So Control A, Z, P, E, Enter sets the baud rate. This just brings you up through a bunch of configuration screens. And then Control A, Z, O brings you the serial port setup. So scroll down to serial port setup, hit Enter, and then hit an F. What you're trying to do is turn off hardware flow control. And that's the critical one. If you don't do that, this doesn't speak. What speaks, but you're not listening to it. And then hit escape twice and you're at a regular session, and then you can go ahead and type in your login information and so on. If you use this from Windows, you can use PuTTY. Okay, and this works from the Windows machines in the collaboratorium. It works from my laptop. I don't know if it'll work from every Windows machine. But what you want to do is basically, if you can get to the device manager, you can plug this in, look at the device manager under ports, see where this thing is connected, COM4, COM3, whatever. If you can't get to the device manager because it wants admin access, open up a command prompt and type the command mode, M-O-D-E, hit enter. It'll show you all the ports that are available. Then plug this in and type mode again. You should see a new port pop up. Usually it's COM4. Okay, open up PuTTY, set this to serial. And under serial line, put in whatever COM port this is, set the speed to 11.5.200. You can save this as a session if you want to avoid typing it in the future. Open it up, and it'll bring you to a connection. And I don't think you have to monkey around with the flow control in that case. It should be set fine. If you're on a Mac, here are the steps that have been reported to work by other students. I haven't tried this, but other people have gotten this to work. So there's a few other steps. Use a program called Screen. You have to install a driver. Okay, whichever way you decide to connect, once you get connected, you'll see some login boot up messages possibly, but eventually you should see a login prompt. Hit enter a bunch of times. Okay, this is one of these things where the more you hit enter, the better, because sometimes it's trying to figure out the baud rate, and that helps it. And it makes you feel better too. Mm-hmm. So eventually you get a login prompt. The username is Pi, the password is Raspberry. Okay, that's standard default for Raspberry Pis. That'll log you in. You have root access in this account. So you can say sudo space any command and it'll execute it as if you were logged in as root. Okay, so if you say sudo rm-rf/, you just wiped out your whole file system. and then you gotta come to me and we gotta rebuild it. So don't do that. You do it the last day. If you want to add your own user ID, there's an add user command. You can look up the man page on it, make yourself your own account. You can figure out the vi sudoer command to give yourself root access and so on. You do want root access because you need it to access the I/O lines. All right, so what are you going to put in your lab report? Basically, I just want to write up everything that you did for this lab, starting with probably how you got connected to it. We had a Mac and we tried this and that and the other thing, and we finally threw it out the window and we went to a Windows machine and whatever, right? But then I want you to do these specific things, okay? And don't think of this as a checklist. I did this, I did this, I did this, I'm done, okay? These are starting points to explore and play around and learn more about this, okay? And think of this as an opportunity to discover your own Linux machine. Okay, 224, we've got a Linux server sitting somewhere, I don't even know where it physically is, and it's just kind of everything's done for us, right? Here it's the opposite experience, right? You get to do whatever you want to this. You get to install software and so on and so forth. So some things I'd like you to play with after you log in, use the df command. That shows you the file systems on the system. So it shows you how much space you have and how it's partitioned out. You should have either 8 or 16 gigabytes of total space on these, depending on how old it is. So take a look at how much space it says you have, how much space it says is in use. Pay attention to the units, because you're just going to get a bunch of like 7 or 8 digit numbers. Is that bytes, is it kilobytes, etc. Okay? And then if you've only got 2 or 3 gigabytes of space in here, it means you haven't expanded the file system yet. And that's going to be the case for most of these. For some reason, it comes up with just a small partition of available space. So there's a command called raspi-config, and you have to run it with sudo in the front. So sudo space command says run this as a super user. So super user do. So do sudo raspi-config, put in your password, which is Raspberry, and it will bring up a little menu of options. And one of those options will be expand file system. And you select that, it says you want to expand the file system, you say yes, and then it says you need to reboot, you want to reboot, say yes. Come back up, log in, do df again, see what your file system looks like now. And you should see more space. You should see a total of either 8 or 16 gig available. Or you may do your df initially and see 8 or 16 gig, it's already been expanded. Okay? So you want to explore this, you want to write a few sentences describing what you did and what you saw. While you're in raspi-config, take a look at some of the other options. There's several options on the first page, and there's one option that says advanced option, and there's several options that are in the advanced option menu. Take a look at some of those, make some speculation, try them out, do some research, and document what 3 other options are that are available in there. Okay, raspi-config is really useful if you want to basically control the disposition of this thing. See what version of Java is installed on the system, okay, because it should have Java pre-installed. See what version it is. The latest version, I think, is version 8, although I don't know 8 point what. See how much memory is available on the system. So the command top will, among other things, tell you how much memory is in use and available. And there's different kinds of memory, so explore that. Okay. If you run the top command, see how many tasks are currently running on your system. You're going to be logged in, you're going to be doing one thing, which is the top command, but you're going to see many, many more commands. And it'll tell you somewhere in that display what the total number of tasks are. So get a feel for what's going on what should be an otherwise quiet system. Then take a look at the directory /boot/exfer and see what's in there, and then take a look at the packages directory and see what's in there. And then run cowsay, just because you got to do that at least once. And put the output in your lab report. You can put it on the cover if you want. And then shut down the system using sudo shutdown-h now. Okay, those are the things I want you to do for lab 1. You're welcome to do more. Okay, but allocate some time for this, right? Maybe like at least an hour, and have some fun with it. Okay, get to know this thing because you're going to be working on it, and you can buy your own Raspberry Pi Zero for $5. right? They're really cheap if you just want to buy one as an individual. And the USB interface, I think, costs about $4. So with that and a few wires, you can make your own version of this. You could print a case on the 3D printer if you want. I can give you the files for it. And it's kind of fun because it's like a Raspberry Pi in your pocket. Full Linux system. All right, so write that up in a report, save it as a PDF, submit it to Canvas. It's due on Friday. And I think the due dates are 8 a.m. again. Same as before. So Lab 1, April 13th. 8 a.m. Yeah, Friday the 13th. Cool, right? All right, any questions about that? Yeah.
So for the formatting, you just want a cover page and two paragraphs on the second page?
So cover page definitely. Put in a sentence saying like what this is, right? So, you know, Lab 1, CSE 223, we were getting familiar with the Raspberry Pi unit, so we did a bunch of experiments. And then, you know, first we connected to it using a Windows machine, and we ran PuTTY, and it worked fine, and so we logged in, and blah, 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 right? But, you know, you're welcome to, like, throw section headings in there and stuff like that, but I'm not going to insist on that. But make it a reasonable-looking report. Those are going to happen.
And the lab reports are individual?
Yes, lab report is for each person, but they're obviously going to have a lot of commonality between them. But write it yourself, right? Don't split it up and copy and paste. Other questions?
Are you still recording these sessions or no?
Yeah. So these will be recorded, and I'll put a link on Canvas later on today. And I'm recording both the morning and the afternoon. Other questions? Yeah.
How are we going to be doing, like if we do like Java ODPs, how are we going to be turning them in if we're using like Eclipse on our own machine?
ODPs you're going to do on the Linux server.
Okay.
So Eclipse will mainly be for the last 4 programming assignments. ODPs will be on the Linux server, and labs will all be on here. And the first programming assignment is on the Linux server also. Yeah?
Using Eclipse is a strict requirement?
I want you to use Eclipse because, yeah, I want you to be familiar with that. There's other development environments out there like IntelliJ and things like that, but I want to keep everybody on a common footing. And Eclipse is, most of these environments are similar to one another, different features, different performance, things like that. But yeah, your submission will be actually in Eclipse workspace, so I'll be unpacking it in Eclipse. Eclipse is, I mean, it will do syntax checking for you. It will format your code, whether you want it to or not. It will create documentation for you. You can say /** right before a function declaration, and it will create a snippet of comments that list all the variables and list the input and list the function name. You just fill in the details, right? And then you can run a command called javadoc, and it'll produce a nice standardized set of documentation on everything that you've written, right? If you make a syntax error, it'll underline it with a squiggly line, and you can put the mouse there and hit Alt-Enter, and chances are it will correct it for you, right? It knows what you're thinking before you do. And you can basically get away with very little understanding of the details of Java, right? That's the Eclipse experience. This is the other end of the spectrum, right? This is VI, compile it at the command line, run it at the command line, do everything yourself, okay? And you really want both experiences. You definitely want to be able to work in a modern environment because somebody's not going to pay you to type in, you know, the 5,000 things you need to type in to create a window in a GUI, right? But you want to know how to do that. You want to know how to be able to do those things. So we want both ends of that experience. So same as last time, ODPs, they'll generally be one day. This first one is a 2-day assignment, so it's due Wednesday. So we've got some time to work on it and ask questions. And there'll be readmes under /temp on the Linux server that tell you the details of the assignment. So let's hop over there. Let's see what we got. So here's ODP 300. This is basically a hello world in Java. So you're creating a class, and don't worry, we're going to spend 10 weeks talking about what classes and objects and Java C and all these things mean. We're just taking this as a template for what we want to do for now. So we want to create a class named myMain that contains a main program that prints out a single line saying hello world. Okay, hello space world exclamation mark new line, that's it. And hey, here's some sample code that just might do exactly that. Okay, so you can copy and paste from here. And over time, we'll figure out exactly what public, static, void, main, all that stuff means, right? But this will work. So the first difference between Java and C that comes up here, in C, we can put our program into any file name that we want. We can call every file bunnydog.q, right? And we can compile that with GCC and it works fine. In Java, if we're creating a class called myMain, it's got to go in a file called mymain.java. Okay, and it will complain if it's in a file with a different name. So you're going to take this code, put it into mymain.java in your own directory. And I suggest getting really good with subdirectories if you haven't already. Right, make yourself a directory for every project that you're working on, every ODP, every programming assignment, and so on and so forth. So mymain.java is your source code. We compile it by saying Java C. Okay, it's just like GCC, but it says compile this Java program. And that's going to create a file called mymain.class. That's kind of like the compiled version of mymain.java. And if you want to execute that, you can just say Java mymain, and it'll run your program, and it should print out hello world on your screen. And you won't always be able to run these programs because you're not always going to be making main programs. But in this case, you are. But you're always going to be assessing these. And here's how you're going to assess this. And this has to be pretty much exactly like this. So assess space. And then the test bench is /temp/mymain-300 space, and then you need to put in the name of your Java program. Okay, mymain.java. And that'll run the assessment system. You can put in the G command and say, go ahead and grade my submission, and it should give you 10 out of 10, and then you're done. You can exit and go on with your life. Okay, you have to run this from whatever directory you did the compile command in. So this first ODP is really kind of dotting the I's and crossing the T's, right? It's figuring out all these nuances. If you do something slightly different from here, it's not going to work. Okay, so try to follow these instructions, and we'll make sense out of these as we move forward. But this will basically be how we assess every ODP in this course. I don't know if that YouTube video link is good or not. I meant to check that and I didn't. All right, so questions about the mechanics of assessing this first ODP? Yeah.
Do you need to include anything, or is that a thing for Java?
Yeah, but for this one, there's nothing to include.
Okay.
But there will be something like includes called an import. That's another thing Eclipse does for you. It'll say, you forgot to import such and such. Do you want me to do it for you? You can say, yeah, and it'll like write it for you. Yeah.
So since this one doesn't have an include, but we are going to standard out, does that just mean that Java always has in and out include?
Yeah, it always understands the basics that you need to do input and output.
Okay.
But you won't need, yeah, there's nothing that you need to actually tell it about. It's this word here, system, is what's actually grabbing the critical stuff.
Your YouTube video works.
Okay. Thank you. All right, any other questions? So here's what I want to do. Let's take a 5-minute break, and we'll come back a little after 12:50, and we'll start talking about Java. I need to leave right at 1:50 after this class on Mondays because I have another class I have to get to. And every time I get comments back from students saying, teacher needs to arrive to class on time. So if you have questions, let's talk about them now or before 1:50. Cool. All right, let's take 5 minutes, and we'll come back and we'll start playing with some Java concepts.
My main.class or .java?
To do